we will be looking at a reaction called the hydrolysis of ethyl acetate. Normally, the hydrolysis of ethyl acetate is catalyzed by either acid or a base. The objective of this experiment is to study the effect of temperature on the reaction in the catalytic packed bed reactor. So there are three stages of procedure for this experiment. One is the construction of the calibration curve. Second, the start of procedure. Third, the experimental procedure. And last but not least, the shutdown procedure. However, today's video, we will be carrying out the hydrolysis of ethyl acetate inside a catalytic packed bed reactor. This reactor uses the strong acid ionic exchange resin as the catalyst.
Okay, first of all, we need to prepare 200 ml of deionized water and then 100 ml of acetic acid. To measure the conductivity in order to prepare the calibration curve, first of all, we need to measure 5 ml of acetic acid. Okay, we measure 5 ml of acetic acid. Okay. And then we pour the solutions into the deionized water. Okay. And then we stir. After we stir the solution, and then we measure the conductivity using the conductivity meter. Okay, the results are obtained in the desktop of the computer. Okay. Okay. And then the step is going to be repeated for another 5 ml of acetic acid until 100 ml is fully used. Okay. After we measure the conductivity using the conductivity meter, we need to insert it into the distilled water in order to flush the conductivity meter. The data for the conductivity can be obtained from this software. So for every run, we need to click Go to read the every reading. Data is read. Okay, we can click Stop. Okay, and then we click the data logger, this one, to read the data that we obtained.
Okay, so now I will show to you on how to operate the catalytic packed bed reactor. So before conducting any experiment using this unit should be flushed first. In the other words, the water should be allowed to circulate around the reactor in order to ensure no chemical residual in the tank or in the reactor. To start the process, all the valves should be ensured to be closed first because we want to fill the water inside the tank. So first of all, we should close the valve because this is the outlet valve for tank 1 and this is the outlet valve for tank 2. So by this process, only for flush, only tank 1 should be filled with water because during the experiment, only tank 1 that will be filled with chemical. So we should flush only tank 1 and the water won't enter tank 2 unless the valve V12 is being opened. And like I mentioned before, the valve is closed in order to ensure this tank is filled with water. Okay, as the tank is being filled, so we will now open the valve V2 to allow the water to enter the system of the reactor at the other side. And in flush process, we must ensure that the water bath temperature or the temperature regulator is switched off because it is just a water circulation process. The pump is function as to pump the water from the tank to the reactor, and as you can see here, there's water being filled inside the reactor, and this is to wash in other words to wash the reactor. And in order to ensure that the water is circulating, all of the valves should be open so the water will only circulate in this unit. The water should be circulated until the reading of the conductivity is going as low as possible. And according to technician, the conductivity won't be zero, so we just wait. For example, we wait for 1 hour and we are monitoring the reading of conductivity, and if it is going low and it is the lowest and the number isn't changing anymore, then we take that as our lowest conductivity that this machine can detect. So after the circulating process or after the flush process, we can flow all of the water inside the tank out, and we can now begin the experiment. Okay, now to start the experiment, we should prepare 20 liter of ethyl acetate solution in tank 1. And this is prepared by first, we are adding the water, 19.2 liter of deionized water. And then we add 800 milliliter of ethyl acetate. And as a precaution, ethyl acetate must be put inside the tank that had been filled with water. We cannot just pour the ethyl acetate itself into the tank because it will damage this machine. And for tank 2, we will be filled with only deionized water for 20 liters. To prepare the solution, we are now adding 800 ml of ethyl acetate into the 19.2 liter of water to make 20 liter of ethyl acetate solution. After we start up and we are now have 20 liter of ethyl acetate solution, now we need to start the experiment to study the effect of temperature on the reaction. But first of all, we need to ensure that our valve is in a correct position, which is in this experiment. We should only open the valve V2. V2 is at the tank, which is where the valve will allow the solution to enter the system. V5, which will direct the water from pump, and V7. And next, we open the pump. And we need to adjust the flow rate to 10 milliliter per minute. And we can adjust it by using the knob here. We just need to turn it until it is 10 ml per minute. As we are studying the effect of temperature on the reaction, regulate the temperature of water bath using this instrument. It can be set to any temperature that we want by operating this like this, which is, for an example, for the start, we want it to be 35 degrees Celsius, so we just increase to 35 degrees Celsius, press enter and press this, which means now the temperature will be set to this desired temperature. And we can see here the increase of temperature, and when it is 35, it will stop increasing. Then that is the moment that we are taking or we are start monitoring the value of Q1 and Q2, which is the inlet and outlet conductivity, and also the temperature of the reactor. It can all be seen in the control panel. That we are concerning here is only TT2, which is the temperature of the reactor. And then the conductivity Q1 and Q2. The reading can only be taken if these three values is not changed anymore over time. So in the other word, it is the moment where the reaction is reached steady state, where the conductivity value and the temperature does not change anymore, and we take that reading. And this process, which is the changing of temperature and monitoring of the reading, is repeated for another temperature, 45 degrees Celsius and 55 degrees Celsius. And all the reading can be tabulated, where from the conductivity we can calculate the concentration of the outlet by extending it in the calibration curve.
Result for this experiment is divided into two parts. first part is for the preparations of calibration curve, and then the second part is for the experimental data of changing the reactor temperature. During the experiment, we obtain the outlet conductivity, and from this outlet conductivity, we can know the conversions by referring to the previous graph. This graph. During the experiment, we obtain the outlet conductivity, and from this outlet conductivity, we can know the conversions by referring to the previous graph. This graph. The reaction rate constant is calculated by using this formula. As we can see, as the temperature increases, the reaction rate constant also increases. The production rate of acetic acid can be increased by increasing the temperature until a certain